Hi all, I am Ram from Oshdata Data Engineering team. We are here to go through a demo on Partition Primary Index in Teradata. So as you know, the distribution in Teradata is always based on the primary index value. The example here given, we have a 4 amp system. The first one is a non-partition primary index and the one below, it's a partition primary index. So in the first case, if we see, if the order number is PI, then we have the order number each on one amp. That is 1028 is in amp 1, 1034 is in amp 2, 1025 in amp 3 and so on. So here if we say select star from orders table where order hash equal to 1028, it directly hits the PI and retrieves the record. So this query is very efficient when we talk about the first case. Now assume there is a query which says select star from orders for order date between 1st September 2007 and 30th of September 2007. So what will happen is it will go to each and every row, find if the condition is matching and then give you the result. But in case of a partition primary index, say if we are creating partitions based on month, see each partition is 1 month, what happens is inside each amp we have the partitions created. So in this case when we save a date between 1st September 2007 and 30th September 2007, the one that is highlighted in yellow, we are directly getting the records from that partitions. Please note here, even in case of partition primary index, the distribution is based on PI, but when we retrieve the records, other partitions are eliminated since partitions are created inside each amp. So from each of the amp, it will get the records from that specific partition. Let's switch on to the demo so that we get some more idea. So I have the scripts created here. This is a Teradata VM, so the performance would be a bit slow, but then too I hope we would be able to have a successful demo. So I've created a database called database training. Okay, here we are creating a partition table which is partitioned on hire date. We have an employee table. So the PI is the employee number and we are partitioning on hire date. So date between 1st Jan 1981 to 31st December 1988, each interval 1 month. What says Jan 1981 would be in partition 1, Feb 1981 would be in partition 2 and so on. So December 1981 would be in partition 12. Similarly, Jan 1982 would fall in partition 13, which is the next one. So we'll just create the table. This demo should give you an idea of what the syntax is and how things work. Okay, this statement is executed. Now what we are doing is we're just inserting a record which is beyond this range. What happens now? Okay, it has thrown an error and it says partition violation for table training.employee part, because we are trying to insert a record where hire date is 1st Jan 1989 and our partition, we have got partitions only till 31st of December 1988. What we do now? So how to add a partition? Here we can add a partition now. So what I say is alter table employee part, modify primary index, add range between first. So I'm just for sake of example, I'm adding a partition which just 1 month. The interval is also 1 month. Okay, this statement is executed. Now I execute the same insert again. This time we have the value inside this table, which is RAM data engineer, date of joining is 1st Jan 1989. Now I've already created an employee table. I have some data inside this. We'll just go through what data we have. Okay, when I say select star from employee, I've got around 13 records. Oh, it's 14. So here, one thing to be noticed is we have a data for 17th of December 1980, which is Smith. Now, when I try to insert this insert, it will throw an error because the partitions are defined only from 1st Jan 1989 and here we have a record for 1980. Okay, it says partition violation for table. Now, instead of adding a new partition of this range just for the demo purpose, what I'm doing is I'm adding something called as no range or unknown. So no range is something that first will execute this. Okay. So no range is something whatever we define, if it is beyond this range, if it doesn't fall in this range, those records will go into no range. Unknown we can see if it is null values. Okay. So now we have 1980 record, which is not in this range, but we are defining no range. So what will happen is this record, that 1981, which belongs to Smith, should go in no range. Okay, so we have inserted all those records into employee part. How do I know which partition is going into which row is going into which partition? So there is something called as partition keyword. So through this we can know it. Okay, so select higher date comma partition. I'm just saying order by partition. So let's see what we are getting. Okay, so Jan 1981 would be partition 1. We do not have a record for Jan 1981, so it starts from Feb 1981. So it goes to partition 2, then April is 4, May is 5, and so on. So if you see at the end, what we have is for 1989, we added a new partition which is gone into partition number 97. Okay, then we have this 1980 which is no range, so it has gone into partition 98. So this is the last partition. Okay, now what I'm doing is we'll make a comparison of the partition table and non-partition table, just the one we discussed earlier. Just insert this record into employee. Okay, now when I say select star from employee where employee number equal to 1001, this gives me two records. Okay, for some reason we have duplicate in this, but fine. So the point that I want to show you was I get the explain for this query. Okay, it's saying by way of a primary index. So employee number is the primary index, employee is a non-partition table, so it is directly retrieving on the basis of employee number, which is 1001. Now what happens if I fire the same query on employee part? Okay. So in case of employee part, what we have is we have the scanning from all the partitions. We are specifying only the PI column, which is employee number. We are not giving any date range here. So what is happening is it is getting from all partitions. So we can have a separate session on how to read and explain, but just from here, just I'm trying to show what how an explain looks. So we'll fire another query and hire date equal to 1st Jan. I don't know if it is the same hire date, but we can run this query and see if we have a record. Okay, so again we have two records here. Now if I execute this query, in this query I'm specifying both the employee number as well as the hire date. So how the explain looks. Okay, so it says from a single partition by way of a primary index. So it is initially, if you see this query, it was all partitions. Now it's single partition. So since we are giving the hire date, it is exactly going into Jan 1989 partition and getting the record for employee number 1001. Now let's see how to drop a range. So as you know, range can be dropped, partition range can be dropped either at the beginning or from the end. So just for example purpose, I'm dropping it from the beginning. So what happens is here we have already added no range recently. So when I drop this partition, first let's execute this command. Okay, so I've dropped this partition. Now, will this record get deleted if the partition is dropped? The answer is no. The reason being, it's 1st Jan 1989. The reason being, we have already defined a no range. So what happens is when we say no range, the data is that if there is no partition, it goes into the no range. So 1st Jan 1989 has gone into now 97, which is the last partition. We dropped a partition, so that number is reduced by 1. Okay, so here we are dropping the partition from the end. So this is the one that we added, and the same thing we are dropping. So I think initially I made the mistake. I told it's dropped from the beginning. We are dropping it from the end. So we are dropping the partition for 1st Jan 1989, and we also saw like how the record looks like. Now, now just take a different example. What I'm doing is again partitioning a table, the same table or the same way, but now I'm giving unique primary index. Initially my employee number was a non-unique primary index. Now I'm trying to give a unique primary index. What happens? Okay, it's saying create table failed and it's saying unique is not allowed. Why unique is not allowed? Anyway, it's a partition table. What happens is in Teradata, especially whenever we define a unique primary index, the primary or the partition column should be a part of the primary index. Why is it so? Because it needs to, if in case if it is allowing, it need to check for uniqueness inside each of the partitions. So that becomes a very uh, what do you say, costly affair for the optimizer. So we'll just see another one. So what I've done here is initially had unique primary index employee number. Now I'm saying unique primary index employee number comma hire date and hire date as my partition column. Let's see what happens. Now the table is created. Since we are having, so I'll just insert this record, inserting the same records. Okay, so 12 rows are inserted. I've given the date range. Now what I'm doing is I'm trying to drop the table. Sorry, drop the range between from this at the start from 1st Jan 1981 to 31st March 1981, and I'm trying to insert it into a backup table. Not sure if the backup table is created, so I can just create it. ctemp underscore underscore bkp as employee, no data. So I'm creating it on the basis of employee. Let's see if this works. Okay, so now I'll drop the range from the beginning. So which is, we can drop it either from the beginning or at the end. So I'm dropping it from the beginning. Okay, now if I say select star from employee underscore backup, whatever is deleted from this table, whatever records are deleted is displayed here. Why? Because this is 22nd Feb 1981 and we are dropping from 1st Jan 1981 to 31st March 1981. So what happened is, in the first case we had no range in the earlier case. So when I dropped the range from the end, it went into no range automatically. But here we have not defined no range or unknown. So that's the reason it's getting deleted and moved into a backup table. So either I can say alter table employee drop range with delete or with insert into another table. Here we are saying insert into another table. So till now we have discussed about range partitions. Now just let's quickly take a look at case based partition. This is another way. So same primary index EMP number, partition by, instead of range n, we are giving case n and we are going it for each department. So we are, and it's no case comma unknown. So there are two ways of defining it. Either you say no case comma unknown, no range comma unknown, or you say no range or unknown. When you say or, a single partition is created for both. When you say comma, there are two partitions, one for no case and one for unknown. So let's execute this command. Okay, so I've created a case table. Okay, and I'm inserting data into it. Okay, I'm checking if I have a record for department 100. Okay, I have two records. So if I get an explain for this, it will show reading from one partition or a single partition. From a single partition, with this case 100. If I'm specifying and employee number equal to something, it will be single partition and by way of single partition and by way of primary index. So how do I check whether there is a skewness inside the partition? So I can just say, for example, here I have the department number as my partition column. So just a query. So this query, I'm saying select partition, department number, count of partition, and count of department number. So anyway, this would be fine. Just to say that you have a partition keyword or a partition column which is inbuilt, you can apply aggregate functions like count on that and also department number. So for department number 100, I have two records or two partitions. Okay, so department number 200, there are 5, and department number 300, there are 8. So total 15 records I have in this table. So this is mainly useful when we have some partition skewness. For example, there are a lot of null values which is going into unknown. So how do you check that? Just put this query and one of the, if one count is very high, you can say that this partition is skewed. Now another example, probably the last one. Last time we discussed if we want to go for a unique primary index, the partitioned column should be a part of the primary index. But what if I don't want to keep that? Is there any way I can enforce uniqueness? The answer is yes. What we can do is we can create a primary index. We can give some partition column other than that, just like partition primary, a non-unique primary index here, and I can create a secondary index over the primary index and enforce the uniqueness. Okay, so this is also a case, probably the only case wherein the PI and an SI can be seen. Okay, so this is executed successfully, just to show that we can have so we can enforce uniqueness by, so what happens is, as told here, a secondary table is created, and inside the secondary table it can check for uniqueness. So, and how do I check how the rows are distributed among amps? This is just an example. So this is a 2 amp system. So which row is going into which amp? This query should help you. So employee number, and what we have put is hash amp of hash bucket. So this is, we have two amps, amp 1 and amp 0. So some of these records are in amp 0 and some of these records are in amp 1. So it's a 2 amp system. How do you know there are number, how many amps are there in your system? Just say select hash amp plus 1. So if you fire this query, you'll come to know how many amps are there in your system. So this is a VM, we have only 2 amps. I'll just run this query. Okay, so here it's 2 amps. So probably that's it for this session. Probably I have not rushed through the things. So yes, this is one interesting case wherein we create a PI, wherein we create SI on the same column as of primary index. But yes, this is possible. That's it from me. Thank you.